Welcome back, students. We will start a new academic year, that's 8th standard. So, in 8th standard physics, total 7 lessons are there for you. So, we will discuss the first chapter, that is force and pressure. So, you know what is force? In lower classes you studied about that. Force means push or pull. In one sentence you will say the answer. Force. What is force? Yeah, it's push or pull. Now, in this chapter, we will discuss what are the different types of forces, what are the effects of forces. Now, pressure, atmospheric pressure, liquid pressure, all those things we will discuss in this chapter. Okay. So, first point, what is force? Force, it's a push or pull. Now, minimum 2 objects should be there for the interaction of force, or minimum 2 objects should be there to force or for force to come into play. For force to come into play, minimum 2 objects should be there. Or we will say it in another way, the interaction of one object with another result in a force between them. When one object interact with another object, then force will be there between the 2 objects. So, minimum 2 objects should be there to force to come into play. Okay. So, force, it's a push or pull, or it's due to the interaction of between the objects. It's due to the interaction between 2 objects or 2 or more objects. But minimum 2 objects should be there to force come into play. Okay. Minimum 2 objects must interact for the force to come into play. Now, in your textbook, activity is given, activity 11.1, page number 128. So many examples are given in your textbook. Moving a book placed on a table. Whether you can move it by pushing or by pulling or lifting, all those things. So, just go through that and tick the appropriate one. So, pushing and pulling. This one is pushing. You are applying a force in this direction. That is pushing. Pulling means this one. Okay, that is pulling. Okay. So, when you push an object, actually the object will move away from you. When you push an object, actually the object will move away from you. When you pull an object, it will it will come towards you. When you pull an object, it will come closer to you or closer to us, or it will come towards us. That is push or pull. Now, you know the SI unit of force, yeah, that is Newton, N-E-W-T-O-N, okay, that is SI unit of force is Newton. So, first thing, that is force, that means it is a push or pull. Force, it is a push or pull. It is due to the interaction between 2 objects. It is due to the interaction between 2 objects. Then SI unit of force is Newton. SI unit of force is Newton. Now, physical quantity. Physical quantity means anything that can be measured. That is considered as a physical quantity. You can measure your height. your weight, okay, length of a table, all those things you can measure. So, that is considered to be a physical quantity. Now, these physical quantities are divided into two categories. One is scalar quantity and the other one is vector quantity. This physical quantity is divided into two main categories. One is vector quantity and the other one is scalar quantity. Now, vector quantity means it is having both magnitude and direction. The quantities which have both magnitude and direction, that is known as vector quantity. Then other category is scalar quantity, that is having only magnitude. Only magnitude. Okay. Length of a textbook or your height. Example, you can take your height 165 centimeter. Whether anyone will say 165 centimeter in the east direction or in the west direction. No. Simply we will say 165 centimeter. Suppose your mother told you to buy 2 kg sugar. You will go to the shop and you will ask 2 kg sugar, isn't it? Whether you will say 2 kg sugar in the east direction, west direction, no. So, 2 kg, that is a mass, 2 kilogram, that is a scalar quantity. Scalar quantity. So, scalar quantity means it is having only magnitude, no direction is there. But other category is vector quantity, it is having both magnitude and direction. This one you will study in detail at 9th standard. Okay, first chapter motion. In that chapter you will study the scalar and vector quantities in detail. Okay. So, vector quantities are expressed in magnitude as well as direction. In magnitude as well as direction, that is known as a vector quantity. The main force is a vector quantity. Okay, force is a vector quantity. We need to specify the direction. In which direction you are applying force? In which direction you are applying force? So, we need to specify the direction. So, that is vector quantity. Now, here this person is pushing a box. This person is pushing. So, this box will move in that direction. The box will move in this direction. The box will move in this direction. So, that is the direction of the force. That is the direction of the force, and in that direction the object will move. In that direction the object will move. Now, suppose an object is here. I am pushing it. I am pushing it. So, this object will move in this direction. I am pushing this object. So, the object will move in this direction. So, this is the direction of motion. Direction of motion. So, in which direction the force is applied? In that direction the object will move. In which direction you apply the force? In that direction the object will move. Now, normally we will represent the force like this, 5 Newton. Here we are not dealing with the direction, only the magnitude part I have taken. Okay. Now, this is the magnitude of force. We can represent it like this, 5 Newton in the east direction. So, this one is a magnitude. A short form I write like this, and this one is a direction. Okay, this one is the direction. Okay, or I can say it, my weight is 62 kg acting downwards. My weight 62 kg acting downwards. So, downwards. This one is a direction. This one is a direction and this one is a magnitude. That one is a magnitude. Now, I am considering only that magnitude part. Only that magnitude part I am considering. So, first example I wrote 5 Newton. Second one I wrote 62 kg. I am considering only the magnitude portion here. This portion consists of two parts. This one is a number part, that is a number part, and this portion is the unit. That portion is a unit. Okay, that portion is a unit. Here, this one is a number part, and this one is a unit. So, when you do problems in higher class, almost all physical quantities will have unit. Certain physical quantities are there without unit is there. Okay. But almost all physical quantities will have unit. So, when you do the problems, according to the number, you have to write the unit also. Then only the whole thing will be complete. Okay. Then only the whole answer will be complete when you do the problems. Okay. That you will, here in 8th standard, 2 or 3 questions are there for you to do. In higher class, the number will increase. So, when you do the problem, you will get the answer, a number will be there, and along with that, its unit you have to write. Okay. So, force, it's a vector quantity, means it's having both magnitude and direction. This magnitude part consists of two parts, one is a number part and the other one is a unit part. Okay. Now, so in which direction of motion is of an object is the direction of the force. In which direction you apply the force, in that direction the object will move. Now, when two or more forces are applied over an object in same direction, two forces are acting on an object in the same direction, how will you find the net force or total force? Okay. Here it is already underlined here. When two forces are applied in the same direction, the total force or the net force can be calculated by the addition of the magnitude of both the forces. Means if two forces are acting in the same direction, we need to add it. Here one example is given. This person, two boys are there. They are pushing a box with a force of 2 Newton each. They are pushing a box with a force of 2 Newton each in the same direction. So, how will you find the net force? You need to add it. That is 2 plus 2, that is equal to 4 Newton. Okay. Then one more problem we will do it. It's a box. Suppose 5 Newton, 4 Newton. Okay, two persons. A will apply a 5 Newton force on this object and B will apply 4 Newton force on this object. How will you find the total force? We need to add both the forces. So, net force equal to net force equal to 5 Newton plus 4 Newton, that is equal to 9 Newton. That is equal to 9 Newton. Okay. Now, when two forces are applied in the opposite direction, then how will you find the net force? Two forces are acting in the opposite direction, then how will you find the net force? Then, how will you find the net force? You can find the net force by taking the difference of the magnitude of two forces. If two forces are acting in the opposite direction, we need to take the difference of the magnitude of the two forces. We need to take the difference, means you need to subtract the magnitude of two forces, then you will get the net force. So, here one example is given, 6 Newton force. 6 Newton force is acting opposite direction. This person applies 6 Newton force, this one also applies 6 Newton force. So, we need to take the difference, means minus. So, 6 Newton minus 6 Newton, 0 Newton you will get the answer. You will get the answer as 0 Newton. 0 Newton you will get the 6 Newton minus 6 Newton, you will get the answer as 0 Newton. Then one more point I added here. The box will not move. The box will not move, means the net force is 0. When you take the difference of 6 Newton and 6 Newton which are acting from opposite direction, we take the difference of these two and find the net force. So, you will get the answer as 0 Newton. In that case, the box will not move. Box will not move. So, this type of force is known as balanced force. Balanced force. Balanced force. Okay. Two forces will be acting in the opposite direction having equal magnitude. Due to the application of these forces, the box or the object will not move. Okay. So, that type of forces is known as balanced force. Now, example is here. Suppose in tug of war competition. Normally, during the Onam season, our school last year also, here we conducted the tug of war competition, isn't it? Suppose two teams are applying the same equal force. Two teams are applying the equal amount of force. Whether the rope will move? The rope will not move. Okay, because their balanced force is there. Okay, from the two sides they are applying equal force. Okay, then the rope will not move. That is an example for balanced force. Okay. Now, here if two persons are applying a force of 6 Newton in one direction and another person is applying a force of 8 Newton in opposite direction, how will you find the resultant force? That you know, we will find the difference. We will find the difference to get the net force. That is 8 Newton minus 6 Newton. You will get the answer as 2 Newton. Okay. Now, we need to specify in which direction the object will move. The object will move in the direction of higher magnitude force. The object will move in the direction of higher magnitude force. That we will do it. Here a box, we are applying 10 Newton and 3 Newton. It's in the opposite direction. In the opposite direction. So, how will you calculate the net force? Yeah, we need to take the difference of these two forces. So, suppose this one is F1, this one is F2. How will you find the net force? Net force equal to F1 minus F2, that is 10 Newton minus 3 Newton. So, you will get the answer as 7 Newton. Magnitude of the net force is 7 Newton. Now, in which direction the object will move? The object will move in the direction of higher magnitude of force. So, the object will move in this direction. This is the direction of 10 Newton force. Direction of 10 Newton force. So, the object will move in this direction. Is it clear? The object will move in the direction of higher magnitude of force. Now we need to solve this one. An object, two forces are applying. Here 3 Newton, here 4 Newton. So, I will draw it here, a box, here 3 Newton, here whatever the number, I forgot the number there in that question, 3 Newton and 5 Newton. So, how will you find the net force? These two forces are acting in the same direction. So, we will find the net force by adding it together. So, net force equal to 5 Newton plus 3 Newton, that is equal to 8 Newton. Then one more question was there. A person, two students are applying a force. Here 10 Newton is there, here 6 Newton is there. They are acting in the opposite direction. Okay, they are acting in the opposite direction. So, how will you find the net force? Take the difference. Take the difference. So, here you will get the answer as net force, you will get it here as 10 Newton minus 6 Newton, that is equal to 4 Newton. Here you will get it as 3 Newton plus 4 Newton, that is equal to 7 Newton. Okay. Now, in this question, how will you find the net force? Here, two forces are acting in this direction, in the same direction. So, here you need to add these two. So, you will get the answer as 10 Newton. Okay, you will get the answer as 10 Newton acting in this direction. Now, another force is acting in this direction, opposite, that is having a magnitude of 7 Newton. So, two forces, this one is 10 Newton, it's 10 Newton, here 7 Newton acting in the opposite direction. So, we will find the net force by taking the difference, that is 10 Newton minus 7 Newton, that is equal to 3 Newton, and it will be acting in the direction of higher magnitude force. Higher magnitude force. So, in which direction 10 Newton is acting? 10 Newton is acting in this direction. 10 Newton is acting in that direction. Okay. I told you about balanced force and unbalanced force. Yeah. Balanced force. Balanced force and unbalanced force. Balanced force means equal force should be acting in the opposite direction. Equal force should act in the opposite direction. Means same magnitude of force will be acting in the opposite direction. That is known as balanced force. So, in case of balanced force, net force will be equal to 0. When you take the difference of the two forces, net force will be 0 and the object will not move. So, this is a balanced force. Here, two elephants are applying 200 Newton. That is in the opposite direction. So, when you find the net force, 200 minus 200. 200 Newton minus 200 Newton, you will get the answer as 0 Newton. So, net force will be equal to 0 and the object will not move in case of balanced force. Now, unbalanced force will be there. Now, here two forces are acting in the opposite direction, but they have different magnitude. So, how will you find the total force? We will take the difference of the two forces. So, that is 12 Newton minus 4 Newton, that is equal to 8 Newton, and that 8 Newton will be applied in the direction of the higher magnitude of force. So, this one is a higher magnitude force. So, the 8 Newton will be acting towards your right side, or the object will move in this direction. The object will move in that direction, means towards the right or towards the 12 Newton the object will move. Now, here net force is not equal to 0 Newton. Net force is not equal to 0 Newton and the object will move. Okay. And the object will move. Then one more diagram is there. One more example is there for you. That is tug of war competition. If balance force is acting, then this rope will not move. Normally a ribbon will be there at the middle of that rope and the rope will not move. Okay. Here it's rocket propulsion, about rocket propulsion. The rockets will be moving in the upward direction. The force of gravity will be acting in the downward direction. Okay. Force of gravity will be acting in the downward direction. Rocket propulsion, the force from the rockets will be acting in the upward direction. Net force will not, that is not equal to 0 Newton. Net force is not equal to 0 Newton. Here net force will be equal to 0 Newton. Here the object will not move. Here the object will move in the upward direction. Object will move in the upward direction. So, I think it's clear to you. Force, push or pull. Then force is due to the interaction between two objects, means minimum two objects should be there. Then if two forces are acting in the same direction, we will calculate the net force by taking the sum. If two forces are acting in the opposite direction, we will take the net force by finding the difference of them. If you got the difference as 0 Newton, means balanced force and the object will not move. If you got the difference not equal to 0 or a number, then that is unbalanced force and the object will move. Okay. So, you have to read the textbook. I will give the notes and you have to copy it in your notebook. Okay. Problems you have to do by drawing the diagram like this. Like this only you need to draw. Okay. No need to draw a box or a ball or anything. Just you can figure it like this. Okay. Thank you.